Welcome back, generals, to another Let's Fix a Generals 0 Hour to make the best game ever. Good, last session we did inquire with Mr. ChatGPT how to get the buffered I/O from the old API to work with the newer API. I don't know what's called. Open API, F-open API. What are the terms for these things? So there's open and there's F-open. But do they have like higher level names? It's weird. Maybe, let's see, where is this defined in which file? Core CRT IO. And this one is in stdio. So a core IO and stdio. Which one is more correct, the core or the std? Std is standing for standard. So yeah, always good to have redundant implementations. Yeah, it gives you more options to choose from. And if one fails, then you have a backup system. Good. So I think we were relatively happy. Maybe we can make all these const here. Yeah. So I think we looked at this yesterday, last session, and we thought that this looked good. Yeah. We can maybe make a follow-up change and add a feature to be able to set the buffer size. No. A little bit of monkey chat here. Yeah, we have adopted the EA monkey slang, yeah, because the game has a lot of monkey references. So if you search for monkey, see here progress bar monkey, pass monkey, monkey on, game text manager monkey, download manager monkey. Yeah. So there are some monkey references in code and in game. Actually, what else is the monkey on? Pass monkey. It doesn't do anything. Oh, that's a shame. Monkey. Jabberwocky. What is Jabberwocky? Oh boy. Yeah. Okay, so where was I going with it? We need to right. So there's a change open. Let me open that. Now I remember what I wanted to say. There's a change open for replay, maybe? Here. So in this change, it will use the RAM file in the different file implementation for the recording for the replay file. Yeah. So I wonder. So a RAM file means it will load all contents of the file in. I say I was thinking about this once more, and there is another simpler solution. Instead of RAM file, we introduce buffer sizes. We introduce custom IO buffer sizes to LocalFile. This way we can set a 1 MB or so buffer, which is large enough for most replays, but will still allow to stream files. It will still allow to stream files if new data comes in. So the benefit of RAM file and streaming the file do not need to be mutually exclusive. I put that here. The benefit of RAM file and streaming. Let's say a RAM file and file streaming do not need to be mutually exclusive. Instead of RAM file, we introduce custom IO buffer sizes to LocalFile. This way we can set a 1 MB or so buffer, which is large enough for most replays, but we're still allowed to stream files if new data comes in. To stream more file, more data if new data comes in. Is that correct though? Would have to test it, right? If you load the whole file with this large buffer, I think I'm not 100% sure this works, but possibly it does, because I think as long as we do not consume the entire buffered IO, the buffered file, do not consume the entire buffered file, the file pointer will not yet have reached the definite end point. I'm not entirely sure, but it's possible. And if that's the case, then we don't need to make it more complicated than necessary. We just say replay file gets a really large I/O buffer. Yeah, humongous. 1 megabyte is good, I think. And then we just read it like this. We could also write it like this. Well, writing is different, needs smaller buffer. But reading, you can use large buffer. And then if new data comes in, then it can still stream. Yeah, I think this could work. Okay, then let me get back here. Okay. Okay, so we have the buffered I/O is activated. Let's see if it compiles. Yeah. And then let's run the game and see if it behaves normal. No. I think switching out all the file I/Os to use actually the game's file system would be a nice goal. Yeah. That all goes through the same system. Right now it's a hit and miss. Some systems do use it, others not. And then there's different file classes. WWLib, there's some other shit. Yeah, that's all probably needs to be unified at some point, so it all goes through the same classes. Why do we have a tab group 2 here? What is this? Fixed. Error. Oh. Error read. Because we don't use it. Read only, else read. Then I think we just remove that. Let's say implicitly reads. Implicitly read only. Implicitly. Maybe we also add this here. Okay. Okay, we load into shell map. That's a start. Let's see if we can write the option file. That's a weird resolution. Okay, but that seems to work. Let's do this. Let's load a nice user map here. Yeah. Scrolling is very slow. Wow, the scrolling is so slow. My gosh. Okay, well, the game runs. Maybe we try against AI. Yeah, let's get some nice hard army. Okay, let's rush him. Oh my gosh. Scrolling so slow. Okay, let's get a dozer down here. Yeah, rush. Oh shit. He's already building here. Uh-oh. Let's build the barracks here for fast, aggressive rush. Yeah, build a bunch of rocket soldiers. Yeah. Let's get the war factory here. Oof. Oof, he's already coming. Oof. Oof. I think we need the laser lock. Oof, toxin tractor. Oof. Oof. It's good that they shoot on my war factory. Just keep spamming. Just keep spamming. We're good, we're good. Let's get a strategy center here. Oof. Oof. Back. Oof. I think we built a little bit too close to the enemy. Uh-oh. No laser lock. The micro. Oof. Getting overrun here. Oof. Okay, but the game works. There. Super micro. Good. Game works. Let's try save load. Save. Amazing game. Saved. Return. Let's load it. Load game. It works. Okay, cool. Then exit. Okay, cool. So, yeah, I mean, if we run into some problem, then I guess we can check. But to me, this looks all correct. ChatGPT was happy with it. Well, he wrote the original draft. Yeah, it just needs to replicate this. Append, truncate, create. Yeah, right. Create. Write only. Huh. Read only. There's no... Is there only a write only? This one writes. Oh yeah. read only. Okay. Yeah, it looks like it makes sense. Hold on. Here it does seek. Is that correct? Seek. It calls the seek function, which is here. Okay, that's probably okay. We need to check these guys as well. Seek smaller than 0. What does that mean? Access append. Else seek. Return f seek. F seek. Okay. Else seek. Else seek. Upon successful completion, LSeek returns the resulting offset location as measured in bytes from the beginning of the file. On error, the value of -1 is returned. An error number is set to indicate the error. And fseek, what does that do? Fseek. 0 upon success, non-zero value otherwise. Okay, that makes sense. ftell. End. Seek. Okay, so they take the same parameters. Okay, I'm a bit confused about this one here. Its position is the second argument, the offset. Where does it say anything about that? Offset bytes. The size of the file plus offset bytes. The file offset is set to the size of the file plus offset bytes. beyond the end of the file. If data is later written at this point, subsequent reads of the file in the gap return null bytes until data is actually written into the gap. Written at this point. So it is valid to set it beyond the end if data is later written at this point. Subsequent reads of the data in the gap return null bytes. Okay, interesting. And FC, can you do the same there? Position of which offsets it can have one of the following values. Shift the position relative to origin. So it looks like it technically will allow to set a positive offset from the end. So, which makes me question this assert here. Let me ask ChatGPT. Given the following function, let me ask here. Given the following function, does the debug assert crash? Assert makes sense. Yes, the debug makes sense, but only if your seek semantics require that seeking from the end must be backwards. This triggers a crash if you try to seek forward from the end of the file. But why wouldn't we want to do that? Go to the end file, move before the end, move past the end. This is legal and expands the file if writing. Yes, if your application logic or engine does not allow seeking past end of file. Seeking relative to seek end is only used for going backward. No, if you expect to support things like growing the file, writing beyond the current end, allowing random seeks even past end of file. This is legal. Do we make use of this seek function then? Let me see that. No, we have some seeks here. Let's search for file ends. File ends. Okay, so we only seek with 0 and with -4 once. Yeah. So to me, it looks like there's no reason that we need to have this. What about what about what about seek set? Would an assert for larger equals 0 make sense there? Yes. Set the file pointer to pos bytes from the beginning of the file. Pos this undefined behavior, invalid in all standard. Yeah, what would actually happen? Would it crash? Fail with an error or result in a runtime crash? Yeah, then how about instead of doing this, we put this here. So the position must be larger equals 0. Local file seek pos must be larger equals 0 when seeking from start. When pos must be 0 when seeking from the start, from the beginning of the file. Yeah, that would be my suggestion. Makes more sense, yeah. How about we run the game with debug turned on and see if we get any errors? Debug. Actually, we can probably just search for file starts and see if there are any negative ones. Seek 0, 0, 0. Commented 0, 0, 0. 10. Yeah. Or 16. Yeah, okay, that looks safe. Bad seek mode. Bad seek mode. Oh, well, we put in a cell here. Bad seek mode. There we go. Debug. Debug crash. There we go. Okay, how about we look at the other places as well? That looks rather innocent, yeah. Afraid, fsake, yeah. If close, file null. Yeah, I think to me it looks good. It's complaining here. MV buff is uninitialized. Oh. Oh, we still got this guy here. Aha. Yeah, that we can remove. Now in the original code, it also had a comment here. This was purely an experiment in optimization. At the present time, it doesn't appear to be a good one. How about we keep that comment? And then we say the super hackers add info. It is a good one. And can be significantly faster than the unbuffered IO for with small reads and writes. It is a good, let's clarify, optimization and can be significantly faster. Will be. Okay, then we should also say here in game defines enable buffered IO in file system. Buffered IO generally is much faster than unbuffered for small reads and writes. Now, I do wonder, like, let's say we want to have a file that is not buffering. Like, for example, if you write out the replay, we maybe don't want to have buffering because we want that every chunk that advances in the replay is actually writing out, so that if the game crashes, we can play back up to exactly this point and have all the information in there, and that there's no like half data at the end which cannot be read or would crash maybe on read or something like this. So it would only write out full chunks always, that you don't lose anything and that there's no partial information dumped into the replay file. And if that's a requirement, then we need to be able to still write buffered IO. And for replay, it's a pretty clear case that this is desired, right? So in that case, you wouldn't want to use buffering. and in similar cases like that. So the question is, with a buffered IO compiled in, which compiles out the unbuffered IO, I wonder if it's still possible, though, theoretically, to use buffering without buffering. Let me ask, using fopen, can that API still be used with quasi unbuffered IO? Yes, you can. Set vbuff, yeah, and just set it to 1 or what? 0. Disable buffering completely, unbuffered. Okay. IONBF. Or use line buffered. Line buffer. Or small buffer. It's a line buffer. Line buffer. Unbuffered IO via fopen is not truly raw. If you're still going through the C runtime level, file descriptor are managed by file, not OS handles. Usually slower than buffered because it issues more syscalls. Yeah. Don't mix freads. Avoid mixing. Yeah. Flush manually. If you do disable buffering, flush manually. Right after fopen. How would we best choose this guy, this or this? Depending on the B mode for fopen. Choosing between unbuffered, line buffered. Oh no, I didn't. I asked the question wrong. I asked the question wrong. I mean, how to decide between this one, that, and that. Only when buffer is full or on flush. Flush trigger. Key difference recap. When new line or buffer is full. When new line is written. Only when buffer is full or on flush. If you're working in text mode, not binary, your bytes are line oriented. Text, access text. Access text. Check if you're writing line oriented text is line oriented. What? But if we provide access text, wouldn't that imply I think we can just say if we set the text flag, then we assume line buffer, right? Would that be fair? I think so. I think so, yeah. Okay, but that's for the next change. That's not for this one. Good. Is there anything else you would like to do? So we have a comment now. We have a comment here as well. No, we don't yet. I didn't finish that. Enable buffered I/O in file system. Buffered I/O generally is much faster than unbuffered for small reads and writes. Maybe put that on the next line. Enable buffered I/O in file system. Maybe we can also say was disabled in retail game. I'd say it was disabled in retail game. Retail game. Okay. Maybe local file. Let's say is implicit. Text is implicit for fopen. Say reads is implicit here if not read write or write writes or writes. Let's put this first as well. Implicit eröffnen. Okay, I think that makes sense. Use buffered IO. We have a typing error here. Then, there we go. Good. Then let me stash that. Let me get latest. Then we do a stash pop. Then we create a new branch. We call that enable unbuffered buffered IO. Then we call this 0 hour. Oh no, this is in core. Core fix and enable. Fix and enable buffered IO in file system. In game engine file system. Okay. Yeah. GitHub. Okay, we also had buffered, unbuffered. Fixes, let's say resolves, reviewers, omniblades, labels, performance, is it major or minor? Oh, it can be major, yeah. It's not critical. Major. Maybe we should say improve and enable, because it wasn't really used before, but there was like an implementation for starters. So that affects both games, Gen and 0R, and that's it. Yeah. This change maybe say enable and improve. This change enables and improves the buffered IO in game engines file system. improves the buffered I/O, not UI I/O. The original implementation was from EA, but it was lacking a few things, which I corrected here, which have been corrected. Measurements have showed that the unbuffered I/O can be 10x slower than the buffered I/O on game starts, on game launch. Have shown they will improve buffered I/O in game engine's file system. How about we say reduce cost of raw file I/O by up to 90% by enabling or I'd say reduces costs by up to 90%. Enable improve buffered I/O in game engine's file system, reduces file I/O cost by up to 90%. or you can say to reduce costs, to reduce its costs. Enable and improve buffered I/O in game engine file system to reduce its cost by up to 90%. Okay. Okay, and then we can make a follow-up change to that. We create a new branch and we say enable buffered I/O 2. And now we think about how we can tell it to use buffering. So we have access 0. Interesting that it defaults to 0. Okay, how would we okay, so we have different, we could say no buffering, right? No buffering, default buffering, line buffering, full buffering. So we have an interface for this. Okay, so there is an access enum. Yeah. A seek mode. Okay, then how about we add a new mode, enum buffer mode. And there we say streaming. Is this ever used? Only new. Never used. Okay, so text binary. There's one more thing I'm curious about. Is the default mode here? Let me ask. Is F open? No, is open? Go. Does open the file? Does the open function open files in text mode if all binary is not specified? Yes. Do not specify, then the file is open in text mode. Okay. Then that is consistent. Okay. Then that is consistent with the other API. Okay. Okay, so okay, let's go back to file. So buffer mode. I don't think we have to actually explicitly tell it a mode because it's already implied through here, right? If we set binary, then we probably want full buffering, only write if the buffer is full. And if we have not binary set or we explicitly set text, then we use line buffering, right? Yeah. And so what is the default buffering modes for fopen? Full buffering. Okay. Even for text modes? Yes, even when opening file in text mode, it still uses full buffering. Why? Does not affect buffering. Let me ask, why would it not flush on new line? By default. Intuitive, yeah, would flush on every new line, but that's not how it works by default. It's not a flush trigger. Buffering mode is. Efficiency. Full buffering improves performance. Maybe what we can say is it only uses line buffering if we explicitly give it the text flag, right? Otherwise it uses full buffering. Could do that, right? write, pen create. Text. Const bool. Text. Text. So we could say do we have as text data. Maybe we say accesses file as text data, as text data. Files by with full buffering, with line buffering. And then we say full buffering if not text. If not text binary. Not text. And not binary. We should specify this somewhere else. We should probably say here none. Access none. Access file for reading by default. Maybe we say here notes. How about we move this here, read write. Uses accesses file as text data with full buffering if neither of the flags, if neither text and binary specified are given. Accesses file as text data with full buffering if neither text and binary are given. Then we have all optionality. Okay, where's LocalFile? LocalFile. We should say with line buffering. With line buffering. With full buffering. Okay, then what we need here is buff size. What is this? Reads enter. Okay. Next line. So we should have here an int, and we say buffer size, and we set it to we set it to -1, meaning unspecified. Yeah. Open a file for access. With default buffer size. Say buffer size of -1 is default buffer size. Opens with default buffer size. Maybe we should add this comment here because it's a bit hard to look at this. Open a file for access. Buffer size of -1 opens with the default buffer size. Let's say negative buffer size opens Okay, and if we specify 0, then we won't have a buffer. If it's larger, then we use this buffer. Yeah. Okay, I think this should be good. So we have local local file. Access none. Maybe we don't need to say access, we just say none. Then we go to, oops, local file. And we also say none here. Then we go to a RAM file. Also none. And then we go to streaming file. Let me just search for all things that inherit this. Just these two. What about streaming file? Streaming file. None. I need water. Okay, good. So open. How about we search for indexes? Maybe that gives a bit easier look on these things. Yeah. Okay. So here we have none. We have a lot of these guys. Look at that. Oh, this one doesn't know what it is. File. Huh. Okay, I'm surprised. Okay, well, too bad. Okay, so it's a little bit cleaned up. Yeah. Okay, then we need to introduce our buffer size. Yeah. What is this? Am open? False. Okay. Huh? Ah. You can also say add 0. Okay. I mean, we don't really do anything with the buffer size in here, but we need to have it anyway because it's a virtual function that we override. Right. So that needs to be here. Okay, so if we go to local file, then we also specify that same thing here. Okay, so buffer size. Good. And we say here, we say if text say if yeah, if let me ask, how do we tell set vbuff to allocate a buffer with default size, with system default size? Okay, the buffer. Ah, right, with just null pointer. I see. 0. But wasn't that to set it to null? To set it to no buffer? Ah, no. Okay, I see. Okay, and we say if buffer size is smaller 0, then we do set vbuff mfile null, and we take the line buffer and we make it 0. That's the default buffer. Otherwise, else say else if this is larger than 0, then we do buffer size. And if that is not the case, then else if it is 0, then we say no buffer. With no buffer, we just need to say disable buffering. And then we say else if buffer size is smaller 0, then we don't need to change anything, right? It's already good to go. Else if nothing to do. Else if buffer size is larger, I mean, we can still be explicit though, right? FPF. I mean, we can still set it, I don't know. The question is this a no op here? This here. Let me put a breakpoint here. This looks correct to me. Then they say this is uses default buffer size. Okay, so I'm curious. Okay, well, first of all, this won't compile because we need to. Well, maybe it does compile, but we need to add this argument to more of the functions. Buffer size. Hold on. This one is not a virtual function. Now here we don't need to specify it. Never mind. Hold on. Where are we? Huh? Here. Now here we don't specify it. The archive file system doesn't have any buffering. What about the RAM file? This one builds on top of this, so this one needs it. This one. This one also needs its buffer size. Okay, now we pass it here, buffer size. Maybe we should keep the zeros here. I mean, it's really not the scope of this change. Oh, this one is a pure virtual. Huh. Then we go to Win32 local file system. And this one also needs it. Then in here, we need to pass it to here. Buffer size. What about this one here? Okay, there's not much going on. Actually, I do like it to be like this. At least here. Okay. Okay. Now, did we miss anything? We still have std local file system. Hold on. Okay. Okay. Anything else? Let's see if they're compiled so we get some errors. Redefinition. Right. It's kind of weird that the RAM file. So the RAM file, it reallocates and then it reads all the data in one go. The RAM file, it's kind of redundant if you just put a large I/O buffer, a large enough, then RAM file is not so much needed. Okay. Still an error here. Right. Okay. So that's already a good start. Yeah. Now the next question is, do we successfully pass it correctly to all sorts of functions or not? I go back to file H. Oof, we can't. Okay, it's not finding file.h. Probably too many things called file. There it is. Access file. Reading by default. Okay, so file system here. Okay. Local file system. This one is also calling it, but this one is not calling it. File open here. Buffer size. There we go. Okay, if we search for open, will we find more cases? So we have this case and this. Video player. Okay, that's different. No, just these two places here. Okay, I think this might be complete. Yeah. Okay, right now everything is opening files with default buffer size, right? Good. Then we have a breakpoint set in here. So we should hit this and this, essentially. One of these. Mostly likely this here, right? But we never hit these guys. Let's see. Okay, now the question is, does this actually do anything, or is it effectively a no-op? Let me go to debug, Windows, disassembly. And we call here into set vbuff, which calls into a function here, which does things. Okay. It calls into functions. It does things. Yeah. Let me ask ChatGPT. Yeah. If we call set vbuff right after, if we call set vbuff right after opening the file, what happens? Is this different from not calling the function at all? Not calling the function with these arguments at all. Calling this immediately after opening file is functionally equivalent to not calling set vbuff at all, because it simply reaffirms the default behavior. Okay. What happens internally? Null for the buffer, tells C on time to allocate its own internal buffer. Where it requests full buffering, 0 for size means uses system default, usually buff sys. Buff sys. Oh, there's actually a default for this. Look at that. Buff sys. Huh. You can say buff sys 512. If the file is a regular file, not a terminal or pipe, and you don't call, then fopen will automatically apply that with the default internal buffer size. Let's see. It's redundant in most cases, but it's perfectly valid when it is useful. You might still want to call it explicitly when you want to ensure consistency regardless of platform-specific default behavior. Aha. Yeah, your code switches between buffered and unbuffered modes based on some flags. You're planning to switch between this depending on context. when it's too late, calling that buff after any IO operation like that results in undefined behavior. So doing it right after fopen is the correct timing. Okay, so it says that maybe it's okay to call it because some other platform might have other default behavior. Okay. Let me say, is there any way to check the buffer size after calling set vbuff? After calling set vbuff, is there any way to check the buffer size? No. Okay. Why not? Okay. Guess based on buff size. If you pass 0, most implementations fall back to buff size. Okay, I guess it's fine. We don't need this information. Okay. Yeah, I think this looks good. So if we explicitly set text modes, then we use line buffering. Otherwise, we use a full buffering in binary or not explicitly text. And then we use no buffer if it has a negative buffer size, aka the default. And that's it. Yeah. Maybe we put the comments. You can say no buffering. Use no buffering. Uses no buffering. Uses buffering. Custom buffer. Uses default buffer. Uses default buffer size. Custom buffer size. Okay. I think that's good. Yeah. Yeah, I think that works. Now the question is, how do we test this? I don't know. I know that on Windows, it doesn't help much to set the buffer above its default size. Maybe you can set it to 1,000. I can't. I did a performance measurement a while ago, and I think there's like an optimal around 1024 and 512. It's really good on SSD, and making it larger doesn't help much really. Yeah. Set vbuff. Let's say default line buffering. Here's this custom default size, custom size line buffering, buffering. Default size, full buffering, custom size, full buffering. Block size. If buffer is a null pointer, resize the internal buffer to size. If buffer is not a null pointer, instructs the stream to use the user provided buffer of size, beginning at buffer. Size of the buffer. The default buffer size buffsys is expected to be the most efficient buffer size for the file I/O on the implementation. But fstat often provides a better estimate. Line buffering is only available for terminal input streams. Zero on success. Maybe we should have an int. Should have a bool here. We say int. Int. Set vbuff results 0. Maybe we say buff results, buff res results. We say here debug assert crash. Do we need to assert? Maybe. Zero. So we say set vbuff fails. Fails. Okay, let's test this. Oof. Oof. Okay. Now that is unexpected. Expression 2 smaller equal buffer and size. Size and... Huh. You're not allowed to pass 0? Huh. Let me ask ChatGPT what he thinks about that. That's unexpected. Calling on Windows gives error. Gives runtime error. This is expected. Yes, that runtime error on Windows is expected. Here's why. Requires a buffer size of at least 2 bytes when buffering is enabled. But you're passing 0. Unlike POSIX systems, Windows does not interpret 0 as use default. Oh, okay. So Windows considers 0 invalid and throws a runtime assertion. Okay. Can we... It's not allowed. Okay. Can we pass buff size on all systems or just on Windows? Yes, you can safely pass buffs on all systems. It is defined by the C standard. Okay. 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 Then let's try that. Buffsys. And for no buffering, we are allowed to pass 0, yeah? Hopefully. Buffsys. Buffer size. Yeah. Okay, well, then let's check that. Well, now given that we typed this here, we don't need to specify how much that is. Someone can look, right? Yeah. Okay. Okay, now he's not complaining. Fantastic. But why did he jump out of there? Why is it not giving me a what? What is the debugger doing? Why is it not stepping onto this line here? What is this? Maybe because we didn't generate yet? Hold on. We didn't generate with debug, right? Not much activity here. It's very quiet today. Oof, what's going on here? It's baby face. Jesus Christ. Oof. 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 It looks like the Discord becomes too much of a meme now. Well, as long as the memes are only in the Discord channel and not on the GitHub, I think it's all good. On GitHub, we should only post professionally, but Discord, yeah, it can be more lax, I guess. Okay, so then let's install. Result 0. So let me see. Let me run again. So if we now step in there, disassembly, call, and we can't see what it's doing here. Can we load symbols? Let me do load symbols. URCT based. So based. This DLL is based. Okay. Aha. 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 Okay, that gives us some information here. Cached. Local. What? What? Set vbuff internal. Okay, I guess that's the interesting function. So it does some stuff here. It's not really clear to me what all this garbage is. Is valid. Full buffering, okay. Log stream and call. It does quite a lot of things here. It calls here some lambda function. Unsafe value, whatever that bullshit is. Oh boy. Force the buffer size to be even by masking the low order bit. I have no idea if it did now anything, or I wonder if it like reallocated something or so. But I hope not. Okay, I have no idea what it did. Let me ask. Does calling that cause a reallocation? Does calling after fopen perhaps cause a buffer reallocation when it was not necessary? Cause a buffer reallocation? Or do we expect the implementation will not reallocate if the requested buffer is the default buffer? The requested buffer is the default buffer. Or is this allocated later on first use? On first read or write? Let me see. Excellent question, of course. The behavior you're asking about can vary slightly by platform and implementation, but here's a breakdown. Standard behavior. When is a buffer allocated? In most standard C implementations, the buffer is allocated lazily, not during fopen, but on the first I/O operation. I see. Unless you call setVbuff with a non-null buffer, then it uses your buffer immediately. What happens when you call? This is safe and does not cause reallocation on most platforms, as the default buffering mode was already that inside, because fopen doesn't allocate the buffer. setVbuff tells the runtime to allocate an internal buffer of buff size later. Since you're not passing your own buffer, there's nothing to free or replace. No unnecessary reallocation occurs. The runtime will allocate a buffer of buff size when it's first needed. If setVbuff is called before any I/O, it fully controls what buffer will be used. A reallocation or replacement could happen only if the runtime had already allocated buffer, and then you call this. But since the C standard requires you to call this guy before any I/O, this case is undefined behavior. Okay. Okay, it makes sense that it would only allocate it on first use, read or write. What we could also do is you could allocate the buffer ourselves. Yeah. Yeah. We could say, yeah, maybe we say we could have here a what is the buffer type? Is it a void or what is it? Char buffer. So what we could do is maybe that we create our own buffer, mbuffer, boof, mboof. Okay. Mfile, mboof, null. And then we say how do we because then we go through our own allocator. That would be the advantage, right? So we can say if we say if mbuff deletes mbuff, but on that note, if we close a file, shouldn't we do the same? If close. Huh. We only close on... Isn't there a close function? There is. Huh. 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 Close is not closing. Close the current file if it is open. Well, it's not closing. What is this? Huh? Okay, that is weird. Close is not closing. I mean, it's closing when it's deleting, delete instance, and then it will close anyway. But the closing should actually be in here, right? That's weird. Yeah. That's weird, yeah. That is weird. I think what this should do instead, we should take this guy. And here we should call close. And then we should go in here. And boof. Now regarding if we if we make an allocation, do we need to pass like a string as well for the game memory allocator or not? Let me search for new in caps. Yes, here message new. But that's only in W3D or? No. Message new. Okay. Then I would say we simply go down up here. I would say how about we say if buffer size equals zero, then we use no buffering like this. Then we say else if text what's the time? 2:30. Yeah, how about we take a break? I will continue next session. Yeah. We leave the code a bit in a chaotic state, but it's okay. Let's continue where we dropped off here in the next session. Yeah. So basically the plan is I want to allocate the buffer and then we pass a buffer here instead of null so that we own the buffer ourselves. The benefit of that is then the allocation for the buffer goes through our game memory manager. So that we can track this allocation in the debugging and it goes into where it's supposed to go. And so I guess that's a bit nicer. Practically it's the same, but it's just a bit nicer, I guess. Yeah. Okay, let's do that next session. But yeah, it looks already promising. Yeah. Good. I will take a break here. I wish you a great day or night. Until next time. Goodbye.